must be for the fundamental theorem of calculus to be applicable? Can anyone help with this?
The natural log of the absolute value of x.
So let's read it one more time. A function must be for FTC, fundamental theorem of calculus, to be applicable.
Differentiable.
Okay,
Continuous.
thank you. If the function is not continuous, the fundamental theorem of calculus is not applicable. Good. We have other situations, but these situations are in Calc 2. When a function is not continuous on the given interval, we have options under certain conditions, but you have to wait till Calc 2. For now, we will have to say, and it's absolutely 100% true, a function must be continuous for the fundamental theorem of calculus to be applicable. Awesome. What about this one? What would you say? The integral from 2 to 5 from 1 over x. Anyone? Anyone would like to give it a try? No one? Just remember that you are muted.
Is it natural log 5 minus natural log 2?
But we have to write this first. And yes, absolutely, you're correct. But we have to write this. This is our first step. And then indeed, natural log 5 minus natural log 2, which if you'd like, you can condense into 1 log. Awesome. What do you think the answer is for this? By odd, I mean an odd function, and by even, I mean an even function. Anyone would like to give it a try?
0.
Yes. What about the other one?
Two times 0 to a
From the function dx. Perfect, awesome. Now, knowing that this interval can be split anywhere, it doesn't have to be in the middle, it doesn't matter. What can we write? Is there anything we can write in here?
I think it's saying it's equal to the integral from a to b plus b to c.
Yes,
For the
indeed.
same function.
Yes, f of x dx, of course. And vice versa. So we can split the integral or we can condense the integral. Perfect, awesome, that's good. Okay, so I'm going to share my screen. I'm just clicking on the chapter. I just did. Oh, sorry. I'm sorry. I'm just going ahead. Any questions? The floor is open for any questions. Anything you worked on. Anything you want to see. You may want to see it again or anything. Anything you need. Any questions? From WebAssign or anything? No questions? Okay, then in that case, let's go to 5.1. We're trying to put things behind us now. So in 5.1, everything is clear, except I wanted to work on a problem to find distance or whatever else they throw at us. Table or graph. So the velocity of a braking car. Why is it braking? Because the slope here is negative. So obviously the speed is decreasing. And we already see that. Use it to estimate the distance traveled by the car while the brakes are applied. So this is one option. Here's the second option. Or table. Anyone would like to pick? If not, I will.
Yeah, let's do the braking one.
Okay, so let's look at 13. So this is in 5.1. So it is difficult from a graph to establish and determine an estimate, but not impossible. So as I see here, you can consider 3 subintervals, or you can consider 6 subintervals. They're not telling us how to do it. It's fine. So I can consider base to be 1, which means I'm looking at 6 intervals. I could consider the leftmost point, which I know it will be in this case an overestimation. I could consider the rightmost point, which I know it will definitely be an underestimation. And so on and so forth. Or I could consider a midpoint, which we know is the best approximation. Which one would you prefer? Leftmost point, which means the height is at the left end of the subinterval. The rightmost point, which means the height will be calculated using the rightmost point of the subinterval, or the midpoint.
Can we do 3 intervals and midpoint?
Let's do so you want 3 intervals or 6?
3 and midpoint makes the...
Perfect. Okay, that's fine. So I'm going to write for now that we are using n equals 3 and the area with mid 3. Good. So first of all, the base. The base is 2. And then I have to have 3 quantities. And remember, so this is 2, 4, and 6. So the midpoint will be at 1. The midpoint will be at 3. And the midpoint will be at 5. So I need in here f of 1, f of 3, and f of 5. That's all I need to determine. I need to approximate f of 1. I need to approximate f of 3 and approximate f of 5. And that's it. So let's take a look. So f of 1, if this is 40 and 50 is somewhere in the middle, this is not that far, right? It's not at 50, right? So this is 1. So I would say a little under 50. Difficult to estimate. So I would say maybe it's exactly between 40 and 50, right in the middle. So I'm going to say 45. And this is in feet per second. So I would estimate this at 45. Okay, I'm going now to f of 3. I will estimate, so 30 is right in the middle, but f of 3 is somewhere here. So it's not halfway between 20 and 30, so it's not 25. I'm going to estimate it at 22. And the last one I have to estimate is f of 5. So f of 5 is right here. It's not at 10, definitely I would say maybe 7. I'm estimating it at 7. So at this point, all I have to do is add these up. So 45, and this is 29, right? So I have 74. So 148. And this is in feet. That's my estimate. Based on, yes, it's maybe not too bad, but of course if I use 6 subintervals, this will be a better estimate than using 3. But the process is identical. Any questions on this, on how we determined the distance? Any questions? Okay. Now I would like to go back and see back to 5.2 and see if we have anything else to discuss there, so we can move on. Here's my 5.2. This was the one that I considered it completed yesterday. Let's see if we have any questions. Did you have any questions on homework? Was everything on homework clear? Did you look at it? I know it's due Thursday, but did you at least look at it or not yet? Let's work on another problem. So I think I selected 14 in 5.2. Let's select another one, similar. So I think you have 14 to work on. So let's choose one from here, whichever you prefer, so we can illustrate again, which is exactly what we just did. But let me know if you need anything from here. Would you like to work on a problem or we move on? It's basically what we just did. Anyone? Is anyone with me?
I'm with you.
Okay. Anyone would like to choose? Or we are clear because we just did problem 13 from 5.1 is the same thing, it's just a different notation. Or we still want to illustrate?
Could we do 13?
Yes. Let's look at 13 in 5.2. So we have the integral from 0 to 3, e to the square root of x dx. Don't try to find the antiderivative of this. It's not going to work. And they want n equals 6 subintervals. And they want us to approximate to 4 decimal places. 4 decimal places. Perfect. And then I would like to show you how to do this with a calculator. Okay. So first of all, they're asking us to use midpoint. I don't like 6 subintervals. It's going to take a while, but it's not a big deal. So first of all, I have to present the interval between 0 and 3. And I have to split it into 6 subintervals. 1, 2, 3, 4, 5, 6. So obviously we have 1 and 2 here. This is 0.5. This is 1.5. And this is 2.5. But we want the midpoint of each subinterval. How do I determine these numbers? Not difficult, because so this piece and this piece are equal, and they are equal to 0.25. So this is 0.25. Then 0.5 plus 0.25 will be 0.75. 1 plus 0.25 will be 1.25. 1.5 plus 0.25 will be 1.75. And 2 plus 0.5 will be 0.25, of course, 2.25. And 2.5 plus 0.25, 2.75. Let me check, make sure that I have correct. 1, yes, correct, correct, correct. Good. So now this will be approximately jump over all these calculations or explanation. This will be, remember we have to have delta x in front. Delta x is 3 minus 0 over 6. So this is 1/2. That's the base. This, 1/2, 1/2, and so on and so forth. So we keep a 1/2 in front. Then I have to have f of 0.25 plus f of 0.75 plus f of 1.25 plus, and this is my page 3. So plus, where am I? Right here. F of 1.75 plus f of 2.25 plus f of 2.75. And now I'm going to show and also record this. I would like to record it so you can see it later on if you want. So I'm going to share my screen, go to the calculator, and where is my recording button? Record on this computer, yes. Now let me clear this and clear this. Okay. More record on this computer, yes. Okay. So we go to stats. We want to edit a list. And I will highlight list L1 at the top, clear and enter. Highlight at the top, clear and enter. I want to remove any of that. The points that I am plugging in, the x values are 0.25, 0.75, 1.25, 1.75, what else? 2.25 and 2.75. The next step, I go and highlight, enter, yes. Go and highlight list L1, list L2, the name. Put 0.5 in front, open a parenthesis. All the entries are in the list L1, so I call the list L1. Sorry, 0.5, parentheses. It's e to the square root, so I need this first. The function is e to the square root of L1. That's our function. Go outside, close. So what will the calculator do? We'll punch in 0.25 in e to the x, multiply by 0.5 for each and every entry, and when you press enter, you will get all the answers at once. You don't have to do this by hand. That will be terrible. Now all I need is to add these up. I get with second and quit, and go to stats, and do a calculation. And the calculation I want to do is one variable stats, the top one, and I wanted it to be on list L2. I want the calculator to calculate the sum of all the entries in list L2. And now looking at all this gibberish, because we haven't talked about all this that we see, which one will you pick? Which one is what we are looking for as the final answer? Which one do you think? From everything you see there.
Probably the second row.
Absolutely, that's the sum. That's why we study that. So this is 10.285666598, and then you stop at the number of digits they want. And I think they said, I wrote it here, 4 decimal digits accuracy. So then I would say 10.2857. This is the area under the graph of e to the square root of x on the interval 0, 3. Is it exact? No. It's an approximation using n equals 6 subintervals and using the midpoint.